Hello, welcome to COP 4708. In the previous session, we created the artist table and we added some constraints. In addition, we added some, a column and some information just to make sure that the table being created. And if you go and browse the tables, you will see that the artist table being created. In addition, I added the customer table, the customer artist interest, the transaction table, and the work table. So if you click on the artist table, you can see the different columns as we stated before and the different constraints that been added. In this session, we'll continue manipulating the table. We are going to drop constraints, then insert some data in that table. Now if you go to data, we don't have any information yet inserted, and we are going to do that using the SQL code. So we're going to drop the constraints first, and we can use that by the statement alter. So we are altering table artist, and we are dropping the constraint that's called valid birth year. And I will save it first as dropping constraint number 1, save, and then I will run it. And as it says here, table dropped, or the constraint being dropped from that table. Then we are going to drop a second constraint. Since we dropped the birth date, we are going to drop the validation for the death year also, and that will be through the alter statement. Save, and this will be number 2. Save, then run, and it's been dropped. If you go to the home page, browse for the object, tables, artist, constraints, and you can see that the 2 constraints that were down here being dropped or deleted. Now let's insert some information in that table. To do that, we are going to use the insert into statement. So it will be insert into the table name, then the different columns that I have in that table, then the values. This is one way to do it. Another way is just to say insert into artist values and so on, because it validates the columns and the values, and if you are missing one of them, it will tell you that you are missing one value, or you are adding an extra value. So you can correct that, and you will receive an error message. So either by using insert into artist, and we add the columns or column names first, then the values, or you can say insert into artist values right away and put these values, and you don't need to mention the columns. Then we are going to save it as insert into artist table number 1, save, then run, and we have 1 row inserted. So if you go to the home page and browse for that object, tables, artist, click on data, and we have 1 row being inserted into the database. We can also update the value. So for nationality, if I need to update it into Canadian, let's see how we can do that. We'll go to the home page, to the SQL code, SQL code, and write the update statement for that row. So I'm updating the table artist. I'm setting the nationality to be equal to Canadian for artist ID number 12. So it will go search for artist ID number 12 and change the nationality to Canadian. And we'll save it as update statement. Save, run, and they're all been updated. If you go to the home page, if you go to the home page to browse for the table artist, look at the data, and you'll see that the nationality being updated into the proper one, or the Canadian one. Now remember that we have a constraint that will check for me if the nationality in this group. So if you added some kind of nationality that's not in this group, it will be rejected or give you an error message that this is not within the range of the valid nationalities. And that's another way to check on the available nationalities or the allowed nationalities. Now, to save time, I actually created the company tables and inserted some data to continue with different SQL commands and statements. Since the company's database being created and the tables being populated with data, let's learn how to display information from two different tables using the join statement. And the join can be inner joins or outer joins. The join allow to combine data from two or more tables into a single result set. The most common type of join is the inner joins. This type of join returns rows from both tables only if their related columns match. Some tables doesn't have a match in a second table. If that's the case, then I will use something called outer join, and the outer join will return rows from one table even if the other table does not contain a matching row, and you'll find it or you see it empty. The statement for the join is the selecting from the different tables. In this case, I'm selecting from the customer the name column and from the artist the name column, and those are my joins, or the new interest, or the customer artist interest join, which is the new table that we created as an interest between the customer and the artist. We have to make sure that the customer ID matches the customer ID in the new table. The join artist from the artist table also matches the artist ID. So we are confirming or checking on the artist ID from artist table and the customer ID from customer table to make sure that there are no values that's not available in these actual tables. Once I do that, or I run the code, I will get this table. Let me run the code for you and you will see how we can do that in Oracle. Again, I'm going to copy paste the code just to save time, and this is the code that we just explained. We are going to save it as join, inner join number 2, save, then run the code, and you can see that it displays the names from the customer, which matches the names from the artist. So actually this customer was buying for the work of this artist, and so on. Now notice that in this column it says name, in this column says name. Sometimes you would like your query or data to be distinguished, so you can add more details to identify it, or to make it more clear for the people that are gonna browse or query behind you. So as an administrator, you can change this to be maybe customer name or C name, and this one is the artist name or A name. Actually, we can use the aliases to create inner join. So instead of using the customer table, we can say C name and A name, where customer is the C and artist is the A, and that will save a lot of the copying or writing the code within Oracle. So we are going to save it as inner join 3, and this is with abbreviation. Save, then run, and we are going to get the same results. So whether you use the whole name or abbreviations, aliases, you can see that that will work for you in both cases. For the outer join, as we said, it will show even the names that doesn't have a matching in the second table. I will save it as outer join 2, save and run, and it will show me the names, all names, again the matching names, whether you have matching table or matching row in the second table or not. In this one I have more than 10 rows available, so I need to increase the selector to view more rows, and that will be in the settings. I will show you an example on how would that show. So if we have Nancy Kevin here that doesn't have artist or did not buy for an artist yet, then you will see it empty in front of her name, and that is the results of the outer join. The outer join will give you everything, even the names that doesn't have a match in the other table, while the inner join will give you only the one that has match in the other table. There are also views that if you would like you to see or query about some of the information from all tables. And again, for the view, you can create or construct a new table that has data from different tables, or from the same table but certain columns and so on. So we use the select statement to define views, which is a subset of the external views that can be used only for external views that involve one multi-valued path through the schema. We use the views to hide columns or rows, display results of computations, hide complicated SQL syntax, layer built-in functions, provide level of isolation between table data and users view of data, assign different processes permissions to different views of the same table, and assign different triggers to different views of the same table. And this is an example of a view, how we can create a view for the customer, just showing customer name. So we are going to use that code and again copy paste it into our SQL screen. Save it as customer table view, save, then run. We are going to change the name here to customer name view number 2, save, and here name it as number 2, save, then run, and the view being created. It doesn't show you the view here, so how can we display the view? What we did or what we created, especially if you have calculations, like if you have quantity, price, and you would like to calculate the extended price using a function or an equation. To do that, we use the select statement, the one that we did in chapter 2, where we can actually display all the information needed. Now sometimes if you put a colon here, might get an error. Sometimes you put the colon and you will be fine. So if the software was giving you an error, just put the semicolon. If not, then just leave it and you will be fine. Save it as displaying the view. Save, run, and it did display for me the customer name in a separate column or a separate table. The updatable views, it's a view based on a single table with no computed columns and all non-null columns present in the view. The view based on any number of tables with or without computed columns, and instead of trigger defined for the view. The possibly updatable views is based on a single table, primary key in view, some required columns missing from the view, update and delete may be allowed, and insert is not allowed. For the possibly updatable views, it's based on multiple tables. Updated may be allowed on the most subordinate table in the view if rows of that table can be uniquely identified. The SQL can be embedded in triggers, stored procedure, and program codes. And the reason for that, you need that trigger to be to start or to begin or to be initiated at a certain point of the code, or if someone did something in the database. For example, if someone tried to delete a row, then you can trigger some kind of error message or alert or something for the administrator, and then the administrator can define who logged in to the system because it has been captured. So we can define who logged in, what did they do, what did they delete, and copy actually the record that's been deleted in a backup database so it can be retrieved or restored later on. So it's very important those triggers and stored procedures that's been used very often to be stored someplace and then called when needed. So those are solutions for some problems that might happen, and usually it's saved in a separate code or a separate file. So what's a trigger? It's a stored procedure or stored program that is executed by the database management system whenever a specified event occurs on a specified table or view. We have three trigger types. We have before, instead of, and after. Each type can be declared for insert, updated, or update and delete, resulting in a total of 9 triggers types. The before with the insert, the before with the update, the before with the delete, that's 3, and so on, and that's total of 9. For Oracle, supports all 9 triggers, while SQL Server supports only 6 trigger types, only for instead of and after. It doesn't have the before. To fire a trigger, the database supplies old and new values for the update, new values for the inserts, old values for the deletions. The way the values are supplied depends on the database management system product. The trigger application, it provides default values and enforce data constraints, update views, and perform referential integrity actions in case of any deletion for the data. This is an example of a trigger that can actually insert a line in case of after insert or update or delete. We can insert a row, and the values for that row will be the values shown here, and that's a new ID for an artist. Then we end that argument and end the whole statement. So begin and end, and then this is the if statement where it gives me the action needed when a trigger being activated. So to fire the trigger, we have to initiate an insert, update, or delete statement. The trigger will begin after that. For example, after inserting into artist values, these values, then that will be triggered, and it will insert another value. This is also an example of trigger code, and this is for the transaction. After inserting a transaction in the transaction table, then we have a procedure to check on the work. Is it been here before or not? Then if not, then this is a new. We will ask for the asking price and the acquisition price, and we ask about the information for that new work. Select the information and add it to the work table. As you can see here, you can add in the triggers, within the triggers, you can add comments that will define the function of each part of the trigger, and that will assist you in debugging the code later on. And this is another example for a trigger that will delete all but the last child. And this does not belong to the artist. Actually, we did not add it to the artist customer or the viewage gallery database. I did not add this, so it's not included in this one, but you can look at the example in the book. The stored procedure is a program that is stored within the database and is compiled when used or when needed. In Oracle, it can be written in PL/SQL or Java. In SQL Server, it can be written in Transact SQL. Stored procedure can receive input parameters and they can return results. And the stored procedure can be called from programs written in standard language by Java, C++, .NET, any kind of interface that we have, especially if you are working with Visual Studio, that can interface with the SQL Server 2005, 2008, any scripting language, JavaScript, Visual Basic Script, SQL command prompt like SQL Plus or Query Analyzer. So we can call it from any of these programs, perform the action needed, and return it back to the database to be used later on. The stored procedure actually can create security, so it has a great advantage for security purposes. It decreases network traffic, and the SQL can be optimized by the database management system compiler. The code sharing resulting in less work, standardized processing, and specialization among developers. This is a code for stored procedure that will show you how this procedure can be used to check on the information within the tables. If needed, then we can update the information in the table or in the database. So it will check if the work is in the database. If not in the database, then insert into work the information, the new information needed, and get a surrogate key value, and that can be done through the sequence that's being created. If you create a sequence for these surrogate keys, a range of numbers, you can bring the information from that and add the new record as needed. Then you can add the transaction for that work. So what's the difference between triggers and stored procedures? Triggers is a module of code that is called by the database then when insert, update, or delete commands are issued. It is assigned to table or view. Depending on the database management system, may have more than one trigger per table or view. Triggers may issue insert, update, and delete commands, and thereby may cause the invocation of other triggers. While for stored procedure, it's a module of code that is called by a user or database administrator. It is assigned to a database but not to a table or view. It can issue insert, update, and delete commands. It's used for a repetitive administration task or as part of an application. That will be all for this session. If you have any questions, please email it to me. Thank you.